Hi everyone, this is your review video for section 5.1, Antiderivatives and Basic Integration Rules. We're going to keep this short and focused, so let's jump right in. Let's start with the big question, what is an antiderivative? So the definition of an antiderivative is f of x is an antiderivative of the function f of x if f prime of x is equal to f of x. In other words, an antiderivative is the function you have to differentiate to get back to what you started with. For example, if you give f of x is equal to 2x, then f of x is equal to x squared. It's an antiderivative because the derivative of x squared is 2x. Simple enough. But here's the catch. X squared plus 5, so for example, x squared plus 5 is also an antiderivative. So is x squared minus 3 and so forth. Because the constants disappear when you differentiate, we'll write the general form as, we'll say the general form is equal to f of x plus c. So this is the general antiderivative. General antiderivative. Where c is called the constant of integration. So, general. The C is not optional. It represents the entire family of antiderivatives. Whenever you compute an indefinite integral, you must include the plus C at the end. Leaving it off will cost you points on the exam. Now, let's just jump into the different rules that we have for integration. So let's look at our first rule. So this is the power rule of integration. So let's say you have the integral of x to the n with respect to x. We say that this is equal to x to the n plus 1, so whatever n is, plus 1, over n plus 1 plus c. The only issue right here is that n cannot be equal to negative 1. And that's simply because if n is negative 1, then the exponent will be equal to 0, and that you cannot derive this. So the idea is simple. You increase the exponent by 1 and then divide by that new exponent. Is that the exact, it is the exact reverse of what you do when you differentiate using the power rule. Now let's do a quick example on how you apply this. So let's do the integral of x to the third dx is equal to, if we apply the rule, we have x 3 plus 1 over 3 plus 1 plus c. This gives us x to the 4th over 4th plus c. So n is equal to 3, so I added a 1 to get 4 and divide by 4. Now we can check this by the antiderivative. So the antiderivative of x to the 4th divided by 4 is 4x to the 3rd divided by 4, which equals x cubed. So that is exactly what we started with, so the power rule works. One other thing to watch out for is the power rule does not apply when n is negative 1 because you'd be dividing by 0. So we'll handle that separately on section 5.2. Now let's look at another rule. This is the constant multiple and the sum difference rules. So real integrals almost never have just one term. So let's talk about two rules that make life easier: the constant multiple rule and the sum add difference and difference rules. Okay, so let's have this. The integral of k times a function f of x with respect to x is equal to k. So we pull out the constant. Integral of f of x dx. So remember, we pull the constant out front. And we also have that the integral of, we had the addition of two functions, so f of x plus or minus g of x with respect to x is equal to, so we can separate them this way, so f of x dx plus the integral of g of x dx. So this, what this is saying is that we integrate term by term. So in plain English, what we're saying is that the constants can be pulled out in front, and you can break up a sum or a difference and integrate each piece separately. So now let's do a quick example. Page. So let's do an example. And in this example, we'll say that the integral of 3 of x squared plus minus x plus 2 dx, this right here, is equal to, so I can pull out the constant for the first one, x squared dx minus 5x dx plus 2 dx. So what is this equal to? This equals to 3 times x cubed over 3 minus 5 times x squared over 2 plus 2x, and we cannot forget about the c. So this is equal to x cubed minus 5x squared over 2 plus 2x plus c. Now notice that the last term, so when we have the integral of 2 dx right here, this is, you could also think of this one as pulling out the 2 and leaving an x to the 0, because x to the 0 is 1 dx. And if you do this, then the integral of this will just be simply x. Okay? Now let's do a quick application on how you would find this in an actual problem. So let's do an example with applications. So we'll say that we are going to connect this to something that you actually find in your field. So let's set up the example right here. So we have that c prime of t is equal to to 6t squared minus 4t with given initial conditions. The c of 0 is equal to 10. And this, where we're looking at the rate of change of a drug concentration, and we need to find the concentration itself. So what are we doing? So we're finding concentration. Okay. So if we want c of t, right? This right here is the integral. So we want to integrate of 6t squared minus 4t dt is equal to 2t cubed. Notice that I already simplified right here ahead of time, but you can, if you need to see the step, you can try it out and make sure you simplify it properly. So this is what we have, our integral. Now if we apply the initial condition, we have that c of 0 is equal to 10. So we have 10 is equal to 2 times 0 to the third power minus 2 times 0 to the second power plus c. So this gives us that c is equal to 10. So our concentration is given by C of t is equal to 2t cubed minus 2t squared plus 10. So notice the initial condition, the fact that C of 0 is equal to 10. Let us spin down the value at a constant C. This is why initial conditions are so important. They take you from the general derivative, antiderivative, to the specific one that fits your situation. So to recap what we covered that an antiderivative of f of x is any function f of x whose derivative is f of x. The general antiderivative always includes plus c, and we have that the power rule is the integral of x to the n dx, which is equal to x to the n plus 1 over n plus 1 plus c, and please just be mindful that n cannot be equal to 1 for the power rule, and the constants pull out and sum and difference split apart. And finally, initial conditions let you solve for c. So this is it for video 1. The next video will cover logarithmic and exponential integration in section 5.2. Good luck.